Welcome back to Algebra 2 Homework Help. Today we're going to be graphing quadratics using a table of values. What do I mean by table of values? Well, we're really referring to XY points where we're going to be plugging in and plotting the points that we get as a result. We plug in for X and then we get out Y and we go ahead and plot those points. Now, a little spoiler alert, whenever we graph a quadratic, that's a function that looks like this. It's got an x squared in it. Our resulting graph is going to look something like this, like a parabola is what it's called, facing up or facing down. But to get the exact and precise graph, that is what our plotting points and what our table of values is going to do for us. It's to get us exactly how this graph goes through x and y. Here are the problems we're going to do today, 1A, 1C, and number 2. Now, before we get right into the homework problems, I want to go over a very important skill set that will be useful when we are plugging in points, and that is the order of operations. We're going to practice here. Please write down example 1 and 2 and try them with me. I'll guide you through the first, and maybe you can try the second one by yourself. So the order of operations is very important that we understand we need to start inside of our parentheses. So when I have this problem, example 1, 2 parentheses, 1 plus 4 whole squared, minus 1. I really need to begin not by distributing this 2, and that's a very common mistake. No. We need to deal with inside of the parentheses first. Whoops, I just erased that. All right, we need to simplify inside the parentheses first. So I'm going to only focus on 1 plus 4. Everything else in my next step, I'm going to rewrite it. So I'm rewriting 2 parentheses. Now 1 plus 4 is 5. Squared minus 1. We dealt with our parentheses first, and now it's time to look at our exponent. So I want you to focus only right here, 5 squared. And 5 times 5 is 25. So in my next step, I'm going to write 2 parentheses 25 minus 1. Again, notice that I did not touch the 2. That is incorrect. We have to do the exponents first. And this 1 is just hanging out for now. We're going in order. Next, we're going to be doing multiplication and division. And in this case, I will finally distribute that too. That's 50 minus 1. And now it's time for our addition and subtraction. And 50 minus 1 is 49. That would be the final answer. All right, let's try number 2 together now. So before we go to number 2, have a look, just a quick recap. First, we focused inside of our parentheses. Only then were we able to use our exponent. After exponent, that's when we did our multiplication, and at the very, very end, we combined using addition and subtraction. So same order, same process. Let's do number 2. Focus inside the parentheses first. So everything else, we're just going to rewrite it. Don't touch anything. 3 minus 5 is negative 2. That gets squared, minus 6. All right, next step. After parentheses, exponent. So carefully, I need negative 2 times negative 2, which is positive 4. So I'm writing this negative is going to get rewritten. Negative. And this became a positive 4, just like that. Minus 6. Now I can add and subtract. I have negative 4 minus 6. Oh, that's negative 10. That's our final answer. So if you're comfortable with this, you're ready to move on to plotting points using a table of values. So here we are, problem number 1A. The function is f of x is negative x squared, and there are really invisible parentheses around this x. I want you to keep that in the back of your mind. So whenever we're plugging in for x, so we're going to begin by plugging in negative 2 here, we need to make sure we're putting parentheses around that negative 2. So have a look. We're going to do it together. Let's find the y value when we plug in negative 2. So here we're going to show our work. I'm plugging this in here, and I'm plugging it in there. So f of negative 2 equals negative parentheses negative 2 squared. Order of operations, we will do exponents first because our inside of our parentheses is already simplified. Negative 2, we can't do much with that. So we're going to square it now. It gives me negative, that's a 4, And hey, we're done. It's -4. Let's try the next problem. So or the next point. We're going to plot, we're going to find the y value when we plug in -1 for x. So f of -1 equals negative, parentheses, -1 whole squared. Again, exponents first. So that's negative. And -1 squared is +1. But the negative out in front stays, so our final answer is going to be a -1. All right, let's try. I would like you to try the next few by yourself. Pause the video here and see if you get the correct answers. All right, check if you got those values the same as I did. So I showed my work here. You can check against that. It's time to plot these points now. So the very first point I'm going to plot is -2, -4. Now remember, our first value, so this guy, is really -2, -4. It's an xy point. So we're going to go -2 on our x-axis, and then we need to go down 4 on our y. 2, 3, 4. Okay, and just plot carefully. Next, I'm going to the point -1, -1. That's right here. And then 0, 0. 1, -1. So go +1 on the x-axis and then down 1 on the y. And then finally, we have +2, -4. Now, notice what's neat about this. We have a symmetrical graph. Once we plot these points together with a smooth curve, notice how each point lined up with one right across from it. And that's because there's always an axis of symmetry. And it's not part of this lesson per se, but you will learn about it pretty soon, which is, hey, this graph is symmetrical about that line I just drew there. The left side maps perfectly onto the right side if I were to fold this graph over that line right there. So that's pretty neat, and that's something that's true about all of our quadratic graphs. So if you ever find yourself plotting points that look a little weird, like this, you plot a point, you plot another point, you plot another point, and it just doesn't seem to line up very nicely, like there is no axis of symmetry, you know you've made a mistake. Your graphs should always, always look symmetrical, like this, symmetrical about this line right here, or even if it's moved off to the corner, it should still be symmetrical, like that. So that was a quick tangent, but let's get back to the problem. There is another part we need to answer. It says, as x approaches infinity, f of x approaches what? So if you remember, this is called end behavior. And I'm really interested in where the graph is going. This means to the right. As I travel further and further to the right, so at the right end of my graph is the height of my graph. This represents the height of the graph. F of x, which is y, remember, represents up and down. So is the height of my graph going up forever towards positive infinity? So is it up here? Or is it going to be down forever? Well, if you focus on the direction of the arrow, right, this is called end behavior. So look towards the end of the graph. On the right side, it's going down forever. So f of x approaches negative infinity. Now we're going to focus on the next piece. As x approaches negative infinity, now our x approaching negative infinity, that's negative infinity. This would be like positive infinity for x. So now I'm talking about the left side of the graph. On the left side, so now focus on the left arrow. Is the graph going up or is it going down towards the negative infinities? And it is indeed going down on both sides, on the right and on the left. All right, now we're interested in where is this graph positive? Positive means it's above the x-axis. This would be where my graph is positive. And notice that the graph isn't positive anywhere at all. In fact, it's below the axis. It's negative the entire time, almost the entire time. So where it says positive interval, we can simply write none. The graph never ever reaches up here. So it's positive nowhere. Okay, increasing interval now. We want to talk about where the graph is increasing. So remember back from the last unit, when we want to talk about increasing, decreasing intervals, we want to scan the graph from left to right. So I'm going to start at the leftmost part of my graph, that's right here, and I'm going to just trace my graph. So ask yourself as you're tracing from left to right, is the graph going up or is it going down? Is it increasing or decreasing? And indeed, it's been increasing this whole time. Ooh, now it's going down, so I gotta stop. Let me go back a little bit. It started here, and I was increasing right until this point. So stop there. Now give me the scanning from left to right. We're focusing on the x values. So since it was from forever on the left side, it's been increasing forever up until this x value of 0, we get to write from negative infinity, that means forever from the left, because it started from here, all the way to 0. I was increasing. Well, that was not too bad, because if I asked you now where it's decreasing, let's say that was the question, well, it's pretty obvious, it's just the other half of the graph. So then that would be from, could you guess? From which x value? That would be 0, and then forever onwards to the right of that point, it is decreasing. See, it's going down, 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 forever and ever. It never stops. Okay, so let's undo some of this mad coloring really quick and come back to the final question. We want to see our vertex. Now, our vertex is the turning point of the graph. And our turning point is right over here at that where we go from increasing to decreasing. So it's the peak or it's the bottom. It's either a max or this would be like a maximum point, or if my graph was facing up, that would be my vertex, the minimum point. So here our vertex is at the point 0, 0, and it is clearly the maximum of my graph. So let's circle max. Ooh, what a problem. Let's try the next one. It should go much faster this time. All right, so again, we're starting with plotting our points. I need to find when x is negative 6, what's the y value of my graph? So again, we're going to plug in f of negative 6 and show all of our work equals 1/2. So we're just plugging negative 6 in for x plus 2. So I just replaced that guy right there with the negative 6. All right, see if you know where we begin. I need to simplify this. So am I going to distribute? No, that would be out of order when we're talking about the order of operations. We got to start inside the parentheses. So let's simplify that. That's 1/2. Negative 6 plus 2 is negative 4 squared plus 1. Next step, after parentheses, exponent. So negative 4 times negative 4 gives me a positive 16. Next, we get to now multiply in that 1/2. 1/2 of 16, so you can put it over 1 and multiply straight across. Gives me 16 over 2, which is really just 8. And then we'll add, our answer is 9. Okay, try the next one yourself. Pause the video, try plugging in negative 4 now. Okay, so if you already tried plugging it in, check if this is what you did first. Simplified the inside. You got 1/2 parentheses negative 2 squared plus 1. After that, you should have done the exponent. So 1/2 negative 2 squared is positive 4 plus 1. And then you did the multiplication here. 1/2 of 4 is 2, and 2 plus 1 is 3. Very nice. Let's do another. Okay, I'm gonna maybe find some room. I'll erase this. I really encourage you to work ahead, pause the video, and try the next 3 by yourself, and then check your work with me. That's how you're going to know whether you were prepared or not, and if you need extra help or if you really do got this. Focus inside. We get 0 squared plus 1. Now 0 squared is just 0. And anything times 0 is just 0. And 0 plus 1 is 1. Let's do f of 0 now. 0 plus 2 squared plus 1. Again, we're focusing inside the parentheses first. That's 1/2. 0 plus 2 is 2. And then we'll do our exponent. 2 squared is 4. Half of 4, and you can show the work. Again, you could show the work over on the side. We'll get 2. And 2 plus 1 is 3. Hey! Oh no, I used the wrong color. I meant to make this blue because it matches nicely with this guy. And then if you go through and show all your work, you're again going to get +9 when you plug in 2. Don't take my word for it though. Try it yourself, and I'm going to prove it right now. So inside the parentheses, we're dealing with 2 plus 2, which is 4 squared. Next, ignore the 1/2. It's there to distract you right now. You've got to use your exponents first. So that's 1/2 times 4 is 16. And then half of 16, that's 8. And finally, 8 plus 1 is 9. And so that checks out. All right, let's plot these points. Starting at -6. 1, 2, 3, 4, 5, 6, comma +9. What was -6? +9 is over here. 2, 4, 6, 9. Got our first point down. Next, -4, comma 3. So go -4 on the x-axis and up 3 on the y. -2, comma 1 should look like that. 0, comma 3, so don't go to the left, go to the right. 0, comma 3 is just straight up. And then finally, 2, comma 9. And we've got another, let's check. Does this look symmetrical? Does it look even on the left and on the right? Not even, but symmetrical, and it does indeed. It looks like it's nice and symmetrical on the left and on the right, okay? So we know that we likely did not make a mistake. Let's answer some questions about this beautiful parabola that we just graphed. As x approaches infinity, now remember, this is where x is infinity, it's all the way to the right. This is where x is negative infinity, that's all the way to the left. So when we say x approaches infinity, you should be focused on the rightmost arrow of the graph. Focus on where it's going to the right. So on the right side, my graph's height is going up forever. So I'm going to say, yeah, it's approaching positive infinity. On the y, it's going forever up. And on the left side, when x approaches negative infinity, that's way over here. So I'm focused on this arrow. My graph is also going forever up. So my y is approaching positive infinity way up here. Cool. Our negative interval. Again, negative interval's way down here. Anything that's below the axis. Does our graph ever go below the axis? It doesn't. It's above the axis the entire time. It never dips down here. So our negative interval is going to be none. Let me ask you a different question though. What if the question had said, what's the positive interval? So that's now asking, hey, where's the graph above the axis? I wonder if you recognize that it's actually the entire time from negative infinity till positive infinity, or basically all the time from left to right, every single solution, or all real numbers. Okay, now we're going to talk about where it's increasing. So again, we're going to start the leftmost part of the graph. Let's start over here. That would be the leftmost part of the graph, and we're going to trace the graph. So is it increasing or decreasing? Well, it's going down. It's decreasing right now. Oh, but we've reached a turning point. So from here, we're going to see, is it going up or down? Now it's increasing. So you got to give me the x value. That x value is -2. And then from -2 till forever onwards, it's going up. It's increasing. Awesome. Now the question is, what's the vertex? Our vertex is that turning point right there, and we can look back to our table. It's at -2, 1. And the question is this the maximum of the graph? Is it the top, the highest value it reaches? Or is it the minimum? It's the bottom. Well, in this case, it's the minimum graph. It's the minimum value. So we're going to circle min. And there you have our answer to problem 1C. All right, this is the trickiest one of the homework assignment, in my opinion. So now we're given 3 graphs, and we're asked to match them to this table of values. So here's what I would do. I'm going to focus one at a time. I'm going to start here at A. And let's pick up a point from this graph. So this graph has a point at -2, 0. It's got let's find another nice and even point. Oh, it hits pretty nicely here at 0, 4. And just with those 2 points alone, I'm going to start matching them up to my table of values and see which one gives me these points. So let's see, at -2, for my x, my y should be 0. Well, over here, -2 is giving me the wrong y value. That should have said 0. So this is not going to be the table for me. Let's look over here. At -2, my y value is 0. Yep, that one checks out. So this checks out, but I'm not done. What if, who knows, what if number 3 also has that? We got to check. So at -2, I'm looking for a y value of 0. When x is -2, oh, that y value is off. So we know that we were actually right on when we said this one matched with letter A. Let's just double check for, just be extra careful. Does our table also give us this point, 0, 4? Well, when x is 0, that's right here, our y value is indeed 4. So we are correct. Let's try matching up B. So find yourself a couple of nice and neat points that work out. We're going to label them. This one looks pretty good. This one looks even better. This 2, 2. So notice that I'm not looking at any of these weird halfway points because we want points that we can exactly identify. We don't want to be guesstimating as to the decimal value. No. I want points that it exactly goes through. So it looks like I've identified a couple right here. Now that I've got my 0, -2, and my 2, 2, I'm going to compare with this table of values, and then we'll look over here at this table. So let's see, 0, -2. Ooh, I found it. That works. It checks out. Let's just try the other one to be careful, extra careful. 2, 2. 2, 2. It works. But let's try this table also just to be sure. Let's see. 0, -2. Oh my God, that one works too. Let's try 2, 2. 2, oh no, this is wrong. So it looks like we had our table over there. Table 1 matched with graph B. So that's nice. So that means C has got to match with table 3, but we're going to check to make sure. So let's use the same method. We'll identify some points and then match them up. Now, you don't have to use the same points as I am. You can try others yourself. But these are, for me, the easiest ones to locate. Now, let's check. When x is 0, is our f of x or our y really -2? Certainly is. And let's check again. When x is 1, that's right here, is f of x really 0? It certainly is. And there we have it. So we're using some matching and some process of elimination to answer these questions. All right, I hope that was helpful. Good luck on the rest of your work.